Good day. I will now discuss to you the lesson on lines and planes in space. So we have here a line represented by this line L, and we have here a vector V which has its initial point at the origin. So we define a line in space that a line into space or T-space can be determined uniquely by specifying a point on the line and a non-zero vector parallel to the line. So as you can see, we have here a line L and a vector V which are parallel. So if we denote this as our point P sub 0, whose coordinates are x sub 0, y sub 0, and z sub 0, then we can now define the equation of line L based on the given point and the given vector V. So we have here the following theorem. So we have the theorem that states the line in two space that passes through the point P sub 0 with coordinates x sub 0, y sub 0, and is parallel to the non-zero vector V equals AB equals AI plus BJ has a parametric equation x equals x sub 0 plus AT, y equals y sub 0 plus BT. Then if we have a line in three space that passes through the point P sub 0 at x sub 0, y sub 0, z sub 0, and is parallel to the non-zero vector V equals ABC equals AI plus BJ plus CK has parametric equations x equals x sub 0 plus AT, y equals y sub 0 plus BT, z equals z sub 0 plus CT. So we call these two equations as parametric equations of lines. Let's have the following examples. It says here, find the parametric equation of the line L passing through the points P and Q, whose coordinates are given. For point P, negative 1, 2, 4, and for point Q, we have the coordinates 3, negative 4, 1. So if you can interpret now the given problem using the XYZ coordinate system and then drawing a line L, so we now have this as so this is now your XYZ axis. Then let us draw line L passing through these 2 points P and Q. Suppose this is your point P, and then this is your point Q. So we have here now a line L. So this is your point P and point Q. Coordinates for point P, we have negative 1, 2, 4. And for point Q, we have 3, negative 4, 1. So in finding the equation of your line L, and we're going to find its parametric equation, we have the formula x equals xo plus at, y equals yo plus bt, then z equals zo plus ct. So with that, let's define x sub o, y sub o, and z sub 0. This will be the coordinates of your point P, which are negative 1, 2, 4. And then for A, B, C here, which is the vector V, let's draw a vector V parallel to line L. And this will be equal to the vector PQ. And in getting vector PQ, we just now define the components, which we have it as terminal point, which is point Q, minus the initial point, which is point P. So we now have 3 minus negative 1, that will be 4. The negative 4 minus 2 is negative 6. Then we have 1 minus 4 is negative 3. So with that, we can now define the parametric equation of the line here as, if we now denote point P as our x sub O, y sub O, and z sub 0. So we now have negative 1 plus your A will be equal to 4, then T. Then Y is 2, which is your Y sub 0. Then your B is negative 6, T. Then we have Z equals, Z sub 0 is 4. Then we have plus CT. C is negative 3, so you have that. So this will be the parametric equation of your line L. If we denote point P as our initial point. So as you can see, we have here the answer. X is negative 1 plus 4t, y equals 2 minus 6t, and z equals 4 minus 3t. Then if you're going to make use of point Q as your initial point, so we will now have the answer as, using point Q, the parametric equation of your line will be XO will be 3 minus, okay, that will be, or rather plus, no? For A, it is positive 4t. Then for Y, we have negative 4, that is your YO. Then your B is negative 6. Then you have Z equals Z sub 0, which is 1. Then you have your C is negative 3. So this is now the parametric equation of your line L when point Q is used as the initial point. So checking now the answer here, x equals 3 plus 4t, y equals negative 4 minus 6t, then z equals 1 minus 3t. So this is how we find the parametric equation of the line passing through these 2 points, point P and point Q. Let's have the second example. It says here, find the parametric equation of the line passing through point P with coordinates 2, negative 3, 4, and parallel to vector V equals 2i plus 3j minus 4k. So again, so what we will do is to draw the x and y axis. So this is your x, y, z axis. Then let us draw a line passing through point P whose coordinates are given 2, negative 3, 4. So suppose this is now your line L whose point P is given. Then we have a vector V whose ijk component is given 2i plus 3j minus 4k, or this can also be written in bracket form, V equals 2, 3, negative 4. So this is now your vector V, which is parallel to line L. So with that, using now the formula, we have x equals xo plus 80, y equals yo plus bt, and z equals zo plus ct. And using now the given coordinates of your point P and the components of your vector V, so we can now write the equation of your line L to be x equals x sub 0, which is 2, plus your A is also 2, then you have t, that is 2 plus 2t. Then for y, we have y sub o is negative 3, then plus we have also here 3 as your b, then t, then lastly we have z equals, z sub 0 is 4, then c is negative 4, so that will be minus 4t. So this is now the equation of your line L parametrically for problem number 2.